Drinking fountains are generally not required to have ground fault circuit interrupter, or GFCI, protection. The reasoning behind this is that the risk of electrical shock from a drinking fountain is considered minimal under normal circumstances. However, there are exceptions to this general guideline. In situations where a drinking fountain is installed in a location where users are likely to be wet, such as near a swimming pool, in a locker room, or in other damp or wet environments, GFCI protection may be necessary to reduce the risk of electrical shock. The specific requirements for GFCI protection can vary depending on the applicable electrical codes and local regulations. It is important to consult the most recent version of the National Electrical Code, or NEC, and any relevant local amendments to determine the specific requirements for a given installation. While I cannot provide the specific code reference, it is beneficial to understand the principles behind GFCI protection and how it applies to different types of equipment and locations. GFCI devices are designed to detect ground faults, which occur where electrical current flows outside of the intended circuit path. This can happen if a person comes into contact with a live electrical conductor and provides a path for the current to flow to ground. GFCI devices quickly interrupt the flow of electricity when a ground fault is detected, typically within a fraction of a second, which can prevent serious electrical shock or electrocution. In the context of drinking fountains, the risk of a ground fault may be higher in wet or damp locations, as water can create a conductive path for electricity. This is why GFCI protection is often required in these types of environments. Conversely, in dry locations where the risk of contact with water is low, GFCI protection may not be deemed necessary. It's crucial to remember that electrical codes and regulations are subject to change and interpretation. Therefore, it is always best to consult with a qualified electrician or electrical inspector to ensure that any electrical installation complies with all applicable requirements. Factors that might influence the decision to provide GFCI protection for a drinking fountain could include the specific design of the fountain, the materials used in its construction, and the environmental conditions at the installation site. For example, a drinking fountain with exposed metal parts that could become energized in the event of a fault might be considered a higher risk than a fountain with fully insulated components. Similarly, a fountain installed outdoors or in an area prone to flooding might be more likely to require GFCI protection than a fountain installed indoors in a dry, climate-controlled environment. In general, it is always better to err on the side of caution when it comes to electrical safety. If there is any doubt about whether or not GFCI protection is required for a particular drinking fountain installation, it is best to consult with a qualified professional and to follow their recommendations. Understanding GFCI protection involves several key aspects. Firstly, knowing what a GFCI device does is important. It monitors the current flowing to and from an appliance or piece of equipment. If there is a difference of as little as 5 milliamps between the outgoing and incoming current, it indicates a ground fault. The GFCI then quickly trips, cutting off the power to prevent electrical shock. Secondly, understanding where GFCI protection is typically required is essential. The NEC specifies locations where GFCI protection is mandatory, including bathrooms, kitchens, garages, outdoors, and other areas where water is present. The specific requirements can vary depending on the addition of the NEC in local amendments. Thirdly, knowing the types of equipment that typically require GFCI protection is crucial. This includes receptacles serving countertop surfaces in kitchens, receptacles in bathrooms, and receptacles located outdoors. Some appliances, such as dishwashers and washing machines, may also require GFCI protection. Now let's delve deeper into the scenarios where GFCI protection might be considered for drinking fountains. In healthcare facilities, where individuals might have compromised immune systems or be more susceptible to electrical shock, GFCI protection might be considered the best practice, even if not explicitly required by code. In educational settings, such as schools and universities, where a large number of people use drinking fountains, GFCI protection might be considered as an additional safety measure, especially in areas where students might be wet or barefoot. In recreational facilities, such as gyms, swimming pools, and water parks, where there is a high likelihood of water exposure, GFCI protection should be provided for all electrical equipment, including drinking fountains. In industrial environments, where workers might be exposed to conductive materials or be operating machinery that could create a risk of electrical shock, GFCI protection should be considered for all electrical equipment, including drinking fountains. When evaluating the need for GFCI protection, it's also important to consider the age and condition of the electrical wiring in the building. Older wiring systems might be more prone to ground faults, which could increase the risk of electrical shock. In such cases, it might be prudent to install GFCI protection even if it's not strictly required by code. Furthermore, it is essential to ensure that any GFCI devices installed are properly tested and maintained. GFCI devices should be tested monthly to verify that they are functioning correctly. If a GFCI device fails to trip when tested, it should be replaced immediately. Regular maintenance and inspection of electrical equipment, including drinking fountains and GFCI devices, can help to identify potential hazards and prevent electrical accidents. The National Electrical Code, specifically Article 210.8, outlines the requirements for GFCI protection. This section details the specific locations and applications where GFCI protection is mandatory. It is important to consult this article to determine the specific requirements for a given installation. There are different types of GFCI devices available, including GFCI receptacles, GFCI circuit breakers, and portable GFCI devices. GFCI receptacles are designed to replace standard electrical receptacles and provide GFCI protection at the point of use. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for an entire branch circuit. Portable GFCI devices can be plugged into standard electrical receptacles and provide GFCI protection for equipment plugged into the device. When selecting a GFCI device, it's important to choose one that is appropriate for the application and that meets all applicable safety standards. It's also important to ensure that the GFCI device is properly installed and wired according to the manufacturer's instructions. In addition to GFCI protection, there are other electrical safety measures that can be taken to reduce the risk of electrical shock. These include grounding electrical equipment, using double insulated tools and appliances, and wearing appropriate personal protective equipment such as rubber gloves and insulated footwear. Grounding electrical equipment provides a path for fault current to flow back to the source, which can help to trip a circuit breaker or GFCI device and prevent electrical shock. Double insulated tools and appliances have an extra layer of insulation that protects the user from electrical shock. Personal protective equipment can provide an additional layer of protection against electrical hazards. Electrical safety is a critical concern, and it's important to take all necessary precautions to prevent electrical accidents. This includes following all applicable electrical codes and regulations, consulting with qualified professionals, and using appropriate safety equipment and procedures. When working with electricity, it's always best to err on the side of caution. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. Remember that electricity can be dangerous, and it's important to treat it with respect. The National Electrical Manufacturers Association, or NEMA, provides a wealth of information on electrical safety and standards. NEMA publishes numerous standards and technical documents related to electrical equipment and systems. These resources can be helpful for understanding electrical safety requirements and best practices. Additionally, organizations such as the Electrical Safety Foundation International, or ESFI, offer educational materials and resources on electrical safety. ESFI provides information on topics such as GFCI protection, grounding, and safe work practices. These resources can be valuable for homeowners, contractors, and anyone who works with electricity. The Occupational Safety and Health Administration, or OSHA, also has regulations related to electrical safety in the workplace. OSHA's electrical safety standards cover a wide range of topics, including wiring methods, equipment installation, and safe work practices. Employers are required to comply with OSHA's electrical safety standards to protect their employees from electrical hazards. It is important to stay up to date on the latest electrical codes, standards, and regulations. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. By staying informed about these changes, you can help to ensure that your electrical installations are safe and compliant. In summary, while drinking fountains may not always require GFCI protection, it is essential to assess the specific installation environment and local code requirements. Wet or damp locations, healthcare facilities, educational settings, recreational facilities, and industrial environments may warrant GFCI protection. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations.